In this video we want to talk about sampling and population. So we want to talk about the idea of sampling and also some techniques that are used in sampling. Now this video overlaps with other videos in the series, so you will see similarities as you work your way through this video with other videos in the series of classes. Anyway, let's start. I want to talk about the sample and population. The target population should be identified through the use of judgment. The population is defined through the objectives of the study. Now what this means is that the target population has to be selected. Well, people do the selection. People have to decide what population needs to be investigated. So it's a matter of judgment. People judge which population is relevant, what information is required. So the objectives of the study must be set out. The objectives may be, for example, to find out what customer needs are, or how customers feel about some product innovation that's been introduced. That could be the objective of the study. Now, which population is going to be selected, which age group, which gender, where they live, which region, these are matters of judgment, matters for the researchers to decide. If the entire population is sufficiently small, then the researcher may include the entire population in the study, in which case the sample is the population, or in other words, there is no sample. The entire population may be studied, but it depends on the size of the population. It also depends, of course, on the resources available for the research activity. If the research budget is small, sampling may still be needed. If the whole population is included, it's called a census study, because data is gathered on every member of the population. So if the whole population is looked at, it's called a census. Usually the population is too large for the researcher to attempt to survey all of its members. So usually a sample is required. Generally speaking, populations are too big. A small but carefully chosen sample can be used to represent the population. Now here, of course, we have to consider the sampling technique, whether it's random or non-random, and we'll talk about this later in this session. We have to decide on how big the sample should be. So care must be taken, if a sample is going to be used, that the sample is representative of the population. The sample must reflect the characteristics of the population from which it is drawn. The sample must have the same characteristics as the population. That's the ideal case. So the average of the sample is the same as the average of the population. The standard deviation of the sample, if measured in these terms, would be the same as the standard deviation of the population. In other words, the sample should be the same as the population. That's the best. Generally speaking, because of issues like bias and sampling errors, there will be a difference. So generally speaking, with sample results, we say, let's say the mean is a certain number plus or minus some percentage, which is, if you like, the tolerance levels. It's the measure of error that is acceptable. So we say that the mean of the population is equal to the mean of the sample plus or minus some. So it falls somewhere in that region. It's going to be in there, in that region. And we'll say is going to be in there with a certain probability. And that's the whole idea of sampling, to work out the characteristics of the population and set up sampling regions, areas of acceptability. So the mean is the same as the sample plus or minus X%. Sampling methods are classified either as probability or non-probability samples. Now, probability samples, each member of the population has a known non-zero probability of being selected. So with probability samples, each member of the population has a certain probability of being selected. And ideally, every member of the population should have the same probability of being selected. Now, probability methods include random sampling, systematic sampling, and stratified sampling. And as I said earlier, these are the subject matter of other videos. But just to recall them here, we have, in this case, 3 methods of probability sampling. So these are our probability methods. There are also non-probability approaches. For example, convenience sampling. Do the most convenient method. Just ask your next door neighbour. It's convenient. It's not very accurate. It's not very representative of the population, perhaps. So it depends on how much weight you want to give to the opinions of your next door neighbour or of people in the local community. Or it's convenience. It's done as a matter of convenience. Judgment sampling, trying to decide on who is to be sampled. Quota sampling is taking a certain proportion of the population and asking them. And snowball sampling is asking perhaps your friends, and then asking your friends to recommend their friends, who will then be sampled, and asking those to recommend their friends again. So it's snowballing. Now we'll look at each one of these in turn very briefly, just to get a picture of what's happening here. Non-probability means that they are not being selected using a probability system. They're not being randomly selected, and hence they're biased. Now, with probability sampling, the sampling error can be calculated. I said earlier that the characteristics of the sample should match the characteristics of the population. Generally speaking, we'd say that the population will be the same as the sample plus or minus some error, some percentage. And we'll say that the population figure will be equal to the sample figure plus or minus some percentage. And that's the advantage of probability sampling. Now let's look at these in turn, just to bring back to mind what they're all about. But let's start by looking at the sampling error. The sampling error is the degree to which a sample might differ from the population. It's the difference between what's calculated in the sample and what the actual figure in the population is. When referring to the population, results are reported plus or minus the sampling error. So we just simply say we've calculated the sample, we found that the average is a certain amount, so the population will be that figure plus or minus some figure. And we are confident to a 95% margin that that is the case, or a 99% margin, or whatever. And that's the idea of using confidence intervals. In non-probability sampling, the degree to which the sample differs from the population remains unknown. It's not probability sampling, so we can't have plus or minus some figure. We just simply say that's what the sample found, and we're not too sure if that is a good, accurate representation of the population figure. Now, random sampling, well, this is the purest form of probability sampling. This is the best type. Each member of the population has an equal and known chance of being selected. When there are very large populations, it's often difficult or impossible to identify every member of the population. So the pool of available subjects becomes biased. With a large population, sometimes we don't know how many are in the population, and therefore selecting, even though selecting randomly, it is biased because it's leaving out the ones we don't know. The best situation is if we know the target population. It may be very large, but if we know the whole size of it and we know all of the respondents or the items in the population, if we knew that, then we could select the random sample. We could select, say, 10% of it, and we'd select those randomly. But if we don't know what the size of the population is, of course, we have a big problem. We are selecting only the ones we know, which could be biased. Now, there are different approaches to random sampling. For example, systematic sampling. Now, this is often used instead of random sampling. After the required size of the sample has been calculated, every nth record is selected from a list of the population numbers. So, first of all, work out how big will the sample be, or should it be, and then pick every 10th member of the population. Or if it's done geographically, pick a street and then pick a house, try and pick those randomly, and then pick every 4th house or every 6th house or whatever. So it's systematic because it started on a random basis. The street was selected randomly, the first house was selected randomly for the survey, and then every 5th house was selected along the way. As long as the list does not contain any hidden order, this sampling method is as good as the random sampling method, providing there's not some strange influence affecting the sample. In a different video I said if the government was sampling attitudes of people towards its economic policy, so it may find that the true situation, let's say, is that everyone was quite depressed about the government economic policy. Just let's say. However, randomly a street was selected, but on this street the people have just won the lottery. They've just won millions and millions of pounds, and everybody on the street was a shareholder in the winning ticket. That means everybody on the street is going to be very happy. Now, the results of a survey based on that are going to report back that everybody is happy, where in fact it was just that one street. It was very unlucky to pick that street because that street is not representative of the population, but possible. So if there is something hidden, some hidden order, systematic sampling is not good. Its only advantage over random sampling is its simplicity. Random sampling can be very complicated. Given a population, let's say people's attitudes, and let's say you want to pick up the people's attitudes across the whole country. If it was possible now to draw a random sample from the whole population, this random sample may be spread right throughout the country. Well, how is it going to be conducted? What's the cost? Researchers travelling all the way around the country, and when they get to somebody's house, the people are not in, they've gone on holiday. Whereas systematic sampling is simple. So that is the advantage of this approach. It's often used when the data is already on computer file and they want to sample from the computer file. They might pick every 10th item every 10th item in the file and use that as the basis of a sample. That might be the case. But it is a simple technique and it is cheaper to use. Systematic sampling. Now let's move to stratified sampling. This is commonly used, a commonly used probability method that is superior to random sampling because it reduces sampling error. It actually reduces the sampling error, so it's a very good technique to use. A stratum is a subset of the population that share at least one common characteristic. Examples of strata might be males or females, or managers or non-managers. So it's possible to see an organization as made up from strata. The managers might be one, the shop floor workers might be another one, or it might be different strata in terms of administration. The accounts section would be one strata, marketing section a different strata, and therefore designing a sample, if it wants to be, if the objective is to be very representative, then of course someone from accounts may be selected, someone from marketing may be selected, someone from the shop floor may be selected, so that opinions across the whole organization are included in the survey. Whereas if it was done randomly, all the employees, all the managers' names may be taken into account and a sample of 10% drawn. But it is possible that 10% are all shop floor workers. So the results of that exercise will be biased towards the opinions of the people on the shop floor. With stratified, the people in the accounts will form one strata. Now they could be randomly sampled and 2 picked out of there. People in marketing will be a different strata. 2 could be picked out of there. And 2 could be picked out of general management. And 2 could be picked off the shop floor. Picked randomly off the shop floor. Now the overall set of results will be representative of all the different parts of the organization. So stratified sampling has got that advantage. The researcher first identifies, the relevant stratum or strata and their actual representation in the population. Random sampling is then used to select a sufficient number of subjects from each stratum. Sufficient means a sample size large enough to give confidence that the stratum represents the population. So that's a technique. It's a good technique because it means that samples can be drawn which are more representative of the population. For example, it may be on a national scale that a survey needs to include male and female. Well, in this case, let's say 50% of the respondents should be male, 50% female. But that may also be subdivided. Age may be an issue. So of the females, a certain proportion should be over 50, a certain proportion over 40, over 30, over 20, and so on. And for the males, the same. So different ways of stratifying the population may be used. Now let's look at convenience sampling. This is used in exploratory research where the researcher is interested in getting an inexpensive approximation of the truth. It's convenience. It's inexpensive and they're getting a rough idea about what actually the truth is in terms of the population characteristics. As the name implies, the sample is selected because they are convenient. It's just a convenient way of getting data. It's a non-probability method. It's often used during preliminary research efforts to get gross estimates of the results without incurring the cost or time required to select a random sample. So it gives a very rough idea. But care must be taken because it is possible to get a very distorted picture from convenience sampling. Another form of sampling is judgment sampling. This is common in non-probability methods. The researcher here selects the sample based on judgment. It may be seen as an extension of convenience sampling. The researcher simply uses his or her judgment to try and select the sample. So it is like convenience. It's biased because it is based on the judgment of the sampler, of the researcher. For example, a researcher may decide to draw the entire sample from one representative city, even though the population includes all cities. So the sampler, the researcher in this case, may pick one place and investigate that one place and then suggest that all the other places, all the other cities, are the same as the one selected. Judgment has been used as to which one has been selected. But of course that may not be the case. Experiences of people in other cities might be different. When using this method, the researcher should be confident that the chosen sample is representative of the entire population. And it's difficult to have that confidence. It's normally just based on judgment. It's what the researcher thinks is fair and reasonable. And in that sense, it is biased. Quota sampling. Well, this is the non-probability equivalent of stratified sampling. Like stratified sampling, the researcher first identifies the strata and their proportions as they are represented in the population. So the researcher identifies the various strata and their proportions, how big are the various strata, in the representative population. Then convenience or judgment sampling is used to select the required number of subjects from each stratum. So having selected the strata, having recognized the strata first and listed the strata, the researcher decides how many will be selected from each one. And that's using judgment again. It's different from stratified sampling, where the strata were filled by random sampling. So stratified sampling was more scientific. It picked members from the various strata randomly. With quota sampling, the researcher is simply selecting from the various strata. The researcher is selecting respondents from the various strata. And of course, that means there will be personal bias in the selection procedure. And the results overall will be biased as a consequence. But again, it's cheap. It's cheap and it's convenient. And it may give some indication. Unfortunately, it may also give the wrong indication and lead to erroneous decisions. So care has to be taken in using quota sampling. The next form is what's known as snowball sampling. This is a non-probability method used when the desired sample characteristics are rare. It may be extremely difficult or costly to locate respondents in these situations. Generally speaking, it may be difficult to find people with certain characteristics, with certain experiences. So because it's so difficult to find the sample, because let's say you're dealing with workers who have particular skills, perhaps old skills that have died out, and the researcher is interested to find out what the skills involved. So let's say the researcher found somebody who had those skills and interviewed that person regarding the skills. Then, because it's so difficult to find other people with the same skills, might ask that particular respondent, does he or she have any friends who worked in that area who would be willing to cooperate? Or any acquaintances who would be willing to cooperate? And the person may know some of his or her old work friends and recommend some. Now the researcher has got more people to interview, and when he or she meets those other people, he or she may ask them to recommend anyone they know. So it's snowballing. It relies on referrals from the initial respondents to generate additional respondents. So you're going from the initial ones to additional. While this technique can dramatically lower search costs, it comes at the expense of introducing bias, because the technique itself reduces the likelihood that the sample will be representative of a good cross-section of the population. So the people interviewed, because they know each other, and because there's a linkage between them, and because it's not randomly selected, a lot of bias may be involved, and the results may not be representative of the population, may not be representative of the true facts that were sought at the beginning. Now let's schematically look at where we've got to. We're looking at types of samples. So we've said we have probability and non-probability. Now with probability we have simple random sampling, which means drawing from the population, drawing a sample of a certain size, and each member of the sample has an equal chance of being selected. We have stratified random sampling, where different strata are identified, and then random selection takes place within each of the strata, so that the researcher is guaranteeing that the various strata in the population are being represented. And then we have cluster random sampling, which means we look to clusters or numbers that share particular qualifications or particular attributes, and then random sample from those clusters. So we may look for people who have certain experiences and identify all the people who have those experiences, and that becomes our new population, and then we draw randomly from those. So that would be cluster random sampling. So a business, for example, would look at all its customers, and then it would look at the customers who only buy a particular product that they make. That's the cluster. And then sample from within that cluster. And that means it's more efficient. It's not wasting research time and effort in looking at the entire customer base, because the entire customer base is not relevant. Only the customers who buy that particular product are relevant, so it's more specific. And of course we had systematic random sampling as well. Systematic was one of the last ones we dealt with. And for non-probability we have convenience, as I said earlier, just a very cheap way of picking the sample, but very biased. Judgment, when the researcher uses his or her judgment to try and cut down the cost of the research activity, but at the same time get some information that may be relevant. Again, the possibility of bias is there. And quota, we've just looked at the end, which is also very biased. It's just looking at a quota of people, or of a subset of the population, which is picked identified and picked by the researcher for sampling purposes. But the results of that activity, of course, are biased. And finally we looked at snowball sampling, which was the one where there was referrals on from one respondent on to his or her friends or acquaintances, and from there on to more. Again, biased, but sometimes it's forced on the researcher because it's difficult to find respondents with certain experiences or certain backgrounds. As I said at the start, a lot of this material overlaps with other videos in the area. We will have looked at stratified and systematic and simple random sampling and so on in other videos. We've also looked at snowball and convenience and so on in other videos. So please look at the other videos as well to get a fuller picture. There are some references you may want to check online which may help as well. So thank you for watching.